Welcome to the deep dive. Today, we're going to be tackling robotics programming with ROS2.
Oh, fun.
Yeah,
Yeah.
we're going to be diving into Ultimate Robotics Programming with ROS2, a book by Jonathan Kakasi.
Excellent book.
Yeah, and full disclosure, I'm already geeking out a bit here.
Okay.
Um, we're not going to turn you into a full-fledged roboticist overnight,
Yeah.
but you'll definitely walk away with enough to impress at your next robotics meeting or project or cocktail party.
That's a good goal.
Yeah. So some of the things that we're going to be talking about today, did you know that there's a whole philosophy behind how robots actually communicate?
Yeah, it's really interesting.
Yeah, and that simulating your robot's controller in a virtual world is, like, essential
Oh, yeah. It's
for things not going haywire in the real world.
yeah, you don't want your robots running amok,
No, not at all.
causing all kinds of problems.
Exactly.
Yeah, so ROS2, it stands for Robot Operating System 2,
Okay.
and it's really the foundation for a lot of modern robotic software.
So this is kind of like the brains of the operation.
In a way, yeah, it provides a very structured and standardized way to build complex robot behaviors.
I see. So it's not just one robot kind of doing its own thing. It's
Right.
like multiple robots working together.
Exactly, and there's this underlying principle called sense plan act.
Sense planet.
Yeah, it's kind of like a loop that's constantly going on.
So it's using sensors to, like, understand its environment.
Exactly. So think about things like cameras, LiDAR, touch sensors, all these different inputs.
Okay. And it's gathering all this information
Exactly.
and feeding it back to, like, its brain.
Right. So it's building this picture of the world around it constantly through those sensors.
Okay, that's sense. What about plan?
So once it has that sensory information, it needs to process it and decide what to do next.
Okay.
And this is where the plan stage comes in.
So it's not just randomly moving.
No, not at all.
It's actually thinking about what the best course of action is.
Exactly. And the plan stage is really driven by the robot's programming algorithms.
So then act must be, like, the execution of the plan.
You got it.
Yeah.
So whether that's maneuvering around an obstacle or picking up an object or, whatever the task may be.
So it's sense plan act.
Exactly. And it's a very elegant way to kind of break down robot behavior.
Yeah. Simple but powerful.
Yeah. Now, when we start talking about multiple robots working together, things get even more interesting because you need to think about how they communicate.
Right, because they can't all just be doing their own thing.
Exactly. They need to be able to share information, coordinate their actions.
So how do they do that?
Well, ROS2 has some very clever communication methods. One of them is called publish subscribe.
Publish, subscribe. What's that?
Think of it like a message board, okay?
Okay.
So one robot might have a camera and it sees something interesting.
Okay.
And it says, hey, everyone, there's a red ball over here.
I like it.
Right. So it publishes that information to the message board. And any other robots that are interested in that information, say a robot that's programmed to fetch red balls, they can subscribe to that topic.
I see. So they only get the information that they need.
Exactly. So you avoid information overload.
Okay, so that's publish, subscribe. What if a robot needs to request something specific from another robot?
Ah, good question. That's where services come in.
Okay.
It's like a direct request. One robot might ask another, hey, what's the distance to the wall? Or can you pick up that object for me?
Gotcha. So publish, subscribe is for, like, general announcements, and services are for these targeted requests.
Precisely. It's a very efficient way to manage communication.
Okay, so now we've got these robots. They're sensing, planning, acting, communicating. There must be a lot of code involved.
Oh, yeah, definitely.
How do you keep all of that organized?
Well, ROS2 has this concept of packages and workspaces.
Packages and workspaces.
Yeah, think of packages as like building blocks of code.
Okay.
So you might have a package for a sensor driver or a package for a navigation algorithm.
So, like, self-contained unit?
Exactly. And then workspaces are like containers for those packages.
Okay. I'm
So
following.
you can have all your code organized in a nice, manageable way.
So if you're working on a robot arm, you might have a workspace for all the arm-related code.
Exactly. And to make things even smoother, we often use Docker.
Docker.
Yeah, think of Docker like giving your code its own little virtual sandbox to play in.
Okay.
So no matter what kind of computer you're using, the code runs the same way everywhere.
So that's for consistency across different development environments.
Exactly. And that's really crucial for collaboration. Avoiding those, it works on my machine headaches.
Yeah, those are the worst.
Oh, absolutely. Now, I know you're a bit of a Python fan.
I dabble.
Well, good news. Python is a big deal in ROS2.
Okay, so I can actually use my Python skills to program robots.
Absolutely. You can create your first ROS2 node.
What's a node?
It's like a little mini program within the ROS2 system. You can create one with just a few lines of Python code.
So it's kind of like the hello world of robotics.
Exactly. But instead of just printing text, you can make the robot do something.
Ooh, now we're talking.
Right. And to make things even more fun, you could create a node that publishes a sinusoidal signal, making your robot move smoothly in a wave-like motion.
Okay, I need to see this in action.
Oh, we'll get there.
That's pretty cool.
Yeah. But before we go too crazy, we need to talk about testing.
Oh yeah, testing's important in any programming.
But in robotics, it's absolutely crucial.
What do you mean?
Well, imagine your robot misinterpreting a sensor, reading and crashing into a wall.
Okay, yeah, that's not good.
Not good at all. So testing is essential for catching those errors early on.
So you're testing for, like, bugs in the code, but also for, like, real-world scenarios.
Exactly. You need to make sure your robot behaves as expected in a variety of situations.
I see.
The book even has this funny anecdote about a calculator node where they intentionally introduced an error in a division operation.
Oh.
And their tests caught it, thankfully, before it could cause any real-world problems.
A rogue calculator, that's scary.
It could be. So testing is something we take very seriously in robotics.
I can imagine.
Okay, so we've got our code tested. We've hopefully squashed all bugs.
Right.
Our robot is ready to go. But do we need to start building a physical robot right away?
Well, I was kind of picturing us, like, with screwdrivers and soldering irons.
Not necessarily. This is where the magic of simulation comes in.
Okay.
ROS2 has this fantastic simulator called Gazebo.
Gazebo.
Yeah, you can create these virtual worlds.
So we can build and test our robots virtually before we even touch any physical hardware.
Exactly. It's like a virtual playground for robots.
Oh, I like that.
Yeah. And in this virtual world, we can experiment, we can iterate, we can break things without any real-world consequences.
Okay, so we've got Gazebo, but how do we describe our robot designs to it?
Well, we use these languages called URDF and Zacro.
URDF, Sacro.
Yeah, they sound a little intimidating, but they're specifically designed for describing robot models.
Okay, so it's like writing a blueprint for the robot, telling Gazebo, this is what it looks like, this is how it's put together.
Exactly. URDF is the base language, but Zacro takes it a step further. It lets us build complex robots in a modular way.
Modular, like Legos.
Exactly. We can create individual components and then assemble them in Gazebo. It keeps things organized and manageable.
That makes a lot of sense. So we've got our virtual robot built in Gazebo. What's next?
Well, we need a way to see what's going on inside our robot as it interacts with the virtual world, right?
Okay, yeah. How do we do that?
That's where RVS2 comes in. It's a really powerful visualization tool, specifically designed for robotics.
So it's like having X-ray vision into the robot's mind.
That's a great way to put it.
Yeah.
You can see sensor data, maps, the internal state of the robot's systems, all in real time.
Wow, so it's like a window into the robot's world.
Exactly. Essential for debugging and understanding robot behavior.
Okay, this is all incredibly cool. We've built a robot in a virtual world. We can see what it's thinking, but how do we actually control it, make it move with a purpose?
Well, that's where we really start getting into the nitty-gritty of robotics.
Okay, I'm ready.
And that's a great place to pick up in part 2 of our deep dive.
Okay, so last time we left off, we built this robot in Gazebo.
Right, our virtual playground.
Yeah, and we were about to dive into how to control its movement, right? Make it actually do something.
Exactly. We talked about the sensing, the planning, even how robots communicate. But to get our robot behaving realistically in the simulation, we need to talk about control systems.
When you say realistic, what do you actually mean? Like, what makes it more realistic?
Well, think about a real robot, right? It's not just going to instantly teleport to a new position.
Right.
There's physics involved,
Okay.
inertia, limits on its motors, friction, all that good stuff.
So it's not just as simple as telling it, move 5 units forward.
Nope. We got to consider the real-world constraints. And that's where ROS2 control comes into play.
ROS2 control.
Yeah, think of it like a framework that lets us simulate the physics of robot control.
So we can define things like how powerful the motors are.
Exactly.
Yeah.
Joint limits, motor characteristics, even gravity.
So we're basically teaching our virtual robot the laws of physics.
Precisely. And this is crucial because we want to test our control algorithms in an environment that mirrors the real world.
Right, so when we actually build it, it's not going to just fall apart.
Exactly. Otherwise, we might think our robot's a genius in simulation, but in reality, It's a total klutz.
Ouch, yeah, I'd rather not have my robot faceplant. So, speaking of these control algorithms, I've heard of something called PID controllers. Are those important here?
Oh, they're foundational. PID stands for proportional integral derivative.
Okay, that sounds a little complicated.
It's really not that bad. These three components basically fine-tune a system's response to a control signal. Imagine you're trying to keep a room at a specific temperature.
Okay.
So the proportional part, it reacts to the current temperature difference. Too hot, cool it down. Too cold, heat it up.
Makes sense. What about the other parts?
The integral part looks at past errors, like has the room been consistently too hot?
Oh, okay.
And the derivative part, that predicts future errors. How fast is the temperature changing?
So it's like predicting whether it needs to start heating up or cooling down in advance.
Exactly, like a super smart thermostat for robots.
Okay, I can see why that would be useful for, like, precise movements. But so far, we've mainly been talking about a robot that's just staying in one place. What about robots that move around, like, those warehouse robots?
Ah, yeah, mobile robots. Those face a whole other set of challenges. First off, they need to be able to keep track of their own movements, which we call odometry.
Odometry, okay.
Basically, it's estimating the robot's position and orientation relative to where it started using sensor data.
So, like, if it has wheels, it's measuring how many times they've turned.
That's one way to do it. It's constantly updating its own map of where it is.
Okay, so that's knowing where it is, but how does it know where to go?
Right. So knowing its position is step one. Then it needs to understand where it is on a map of the environment that's localization.
So, like, I'm at point A on this map, and I want to get to point B.
Exactly. And once it knows where it is and where it wants to go, it needs to figure out the best route path planning.
Avoiding obstacles and stuff, right? Like, it can't just bulldoze through walls.
Definitely not. That's where things like obstacle avoidance algorithms come in.
It's a lot for a robot to think about. Do we have to program all of this ourselves?
Thankfully not. ROS2 has this awesome navigation stack called Nav2.
Nav2, like Navigation 2.0.
You got it. Handles odometry, localization, path planning, all that good stuff. We don't have to reinvent the wheel, so to speak.
Oh, I see what you did there. So Nav2 is basically like giving our robot a GPS, a map, and a super smart route planner all in one.
You got it. It's pretty powerful. And there's even more. To make obstacle avoidance even more intuitive, we can use something called the artificial potential field.
Okay, now you're just showing off. Artificial potential field. What is that?
Imagine this. The robot's goal is like a magnet pulling it towards the destination.
Okay, I'm picturing it.
But then obstacles create these repulsive forces, pushing the robot away.
So the robot is navigating this invisible force field, trying to get to the goal without bumping into anything.
Exactly. It's a cool way to visualize how the robot makes decisions in real time.
I'm telling you, this is blowing my mind. We've gone from Sense Plan Act to robots navigating a whole world.
It is pretty amazing what we can do with ROS2, right?
Absolutely. So what else does the book cover? Is there even more to this?
Oh, definitely. It even gets into things like behavior trees, which are used for programming more complex robot behaviors.
So instead of just following a set path,
Right.
the robot can actually make choices based on its environment and goals.
Exactly. Imagine you're programming a robot to clean up a room.
Now, that's a robot I need.
Using a behavior tree, you could have tasks like pick up clothes, put away toys, dust furniture, all that. And the robot can choose which task to do based on what the room looks like at that moment.
So it's like giving the robot a set of instructions, but also the freedom to decide the best way to carry them out.
You got it. And to help with that decision-making, there's this concept of a blackboard. Think of it like the robot's mental whiteboard, where different parts of the behavior tree can communicate.
Okay, so the robot's like, all right, clothes first, then toys. It's keeping track.
Exactly. And ROS2 works really well with this library called PyTrees, which makes it easy to use behavior trees for real robots.
Wow, so this is getting pretty advanced. But before we go too deep into behavior trees, I want to circle back to something we talked about earlier, computer vision. We talked about robots sensing their environment, but this is about actually seeing, right?
Exactly. Computer vision lets robots perceive and interpret visual information. It's a whole other level of perception.
So we're not just talking about like detecting light and dark anymore. They can actually recognize objects.
Oh yeah, ROS2 uses OpenCV, a powerful library for image processing. We're talking edge detection, shape recognition, object tracking, even 3D reconstruction.
So we could tell a robot to find a specific toy, and pick it up.
You got it. And remember those Aruko markers we talked about before?
The square ones with the patterns?
Yeah, those are super useful for computer vision.
Yeah.
A robot with a camera can see an Aruko marker and immediately know where it is and how it's oriented.
So it's like a visual landmark for the robot.
Exactly. Navigation, object tracking, even augmented reality. Aruko markers are great for all sorts of things.
This is incredible, but it also makes me think that testing is even more important now, right?
Absolutely. Testing in robotics is absolutely essential, especially with these more advanced capabilities.
I mean, now it's not just about a bug in the code. It's about making sure the robot doesn't, like, accidentally run into someone.
Right. We have to make sure our robots behave safely and predictably in the real world.
So how do we even test for that? Is it just like more code?
It's a multi-layered approach. We have unit tests, checking individual components in isolation. Then integration tests, making sure different parts work together smoothly.
So we test the wheels, the motors, the sensors all separately, and then together as a system.
Exactly. And finally, we have system-level tests where we evaluate the whole robot in a simulated or even real-world environment.
So like an obstacle course for robots.
Pretty much, we put them through their paces, make sure they can handle different situations.
So this testing process, it's kind of like a final exam before we let these robots out into the world.
That's a great way to put it. Rigorous testing is what gives us confidence that the robots we build are safe and reliable.
Okay, I'm really feeling the importance of testing now. So we've talked about how W to build these robots. But now I'm kind of curious about WHY. What are some of the real-world problems that ROS2 and robotics are helping us solve? Like, it's not just science fiction anymore, right?
Oh, absolutely not. Robotics is rapidly becoming part of our everyday lives, and ROS2 is leading the charge.
So where are we seeing these robots making a difference? What are they actually doing out there?
Well, manufacturing's a big one. We're seeing more and more collaborative robots or cobots that can work alongside humans.
So it's not about replacing human workers, it's about, like, teamwork.
Exactly. Cobots can handle the repetitive or dangerous tasks, freeing up humans for more complex work. It's a win-win.
That's pretty cool. What about other areas? Like, are there robots in healthcare?
Oh yeah, healthcare is another exciting area. ROS2 is being used to develop surgical robots that can assist surgeons with incredibly precise movements.
Wow. So they're like super steady robotic hands.
Exactly. And we're also seeing rehabilitation robots that can help patients regain mobility after injuries. It's pretty incredible.
So robots are literally helping people heal? That's amazing.
It is. And even in agriculture, ROS2 is helping develop robots that can plant, weed, and harvest crops.
Robots are becoming farmers.
It's happening. It can increase efficiency, reduce the need for manual labor, and even help with food security. It's a big deal.
Okay, I'm officially living in the future. Robots in factories, hospitals, farms. This is wild.
It is pretty wild. And we're just scratching the surface. ROS2 is also being used in logistics, exploration, search and rescue, all sorts of things. The possibilities are endless.
So what you're saying is if someone is listening to this and thinking, this is amazing, I want to be a part of this, it's not just a pipe dream, right?
Not at all. Robotics is a field that's open to anyone with the passion and drive to learn.
Okay, so where would someone even start? What would you recommend?
Well, first, just be curious. There are tons of online resources. Check out the ROS2 documentation, play around with robotics kits. Don't be afraid to experiment and even make mistakes. That's how you learn best.
So get your hands dirty, try things out, don't be intimidated.
Exactly. And join the ROS2 community. There are so many people who are passionate about robotics and willing to help each other out.
That's great to hear. So anyone can be a part of this robotics revolution.
Absolutely. Whether you're writing simple code or designing AI-powered robots, it all starts with that spark of curiosity.
I love that. So we've covered a lot of ground in this deep dive, from the basics of ROS2 to robots that can navigate, see, and even learn.
It's been quite a journey.
But before we wrap things up, there's one more question I have. We've seen what robots can do NOW, but what about the future? What's on the horizon? What trends should our listeners keep an eye on?
Ooh, that's a great question, and a perfect place to pick up in part 3 of our deep dive.
Okay, so we've come a long way in our deep dive into ROS2.
We have, from Sense Plan Act to virtual robots, computer vision, even touched on those Aruko markers.
Yeah, it's been pretty mind-blowing, but now I want to look ahead.
It's to the future.
Yeah. What's next for robotics? What's coming down the pipeline?
Well, one trend that's really gaining momentum is the fusion of artificial intelligence, AI, with ROS2.
AI and robots. Okay, now we're talking sci-fi.
It is kind of sci-fi, but it's becoming reality. Imagine robots that don't just follow instructions, but can actually learn and adapt.
So they're not just reacting, they're thinking, making decisions.
Exactly. Robots that can learn from their experiences, analyze data in real time, and make choices based on that information.
What kind of AI are we talking about here?
Machine learning algorithms, computer vision, natural language processing. We're talking about robots that can see, understand language, and learn.
Okay, that's next level. But how does this actually work? Like, how do you combine AI with ROS2?
Think of it like this. ROS2 provides that solid framework for controlling the robot's actions, its movements. But the AI adds the brain power.
So ROS2 is the brawn, and AI is the brains.
That's a great way to put it. They work together.
So what can we do with this powerful combo? What kind of real-world applications are we talking about?
The possibilities are huge. Imagine AI-powered robots helping out in hospitals, monitoring patients, delivering meds, even providing companionship.
That would be amazing, freeing up nurses to focus on other things.
Exactly. And in logistics. Imagine self-driving delivery robots, navigating busy streets, bringing you packages or groceries right to your door.
Robot delivery. Sign me up.
But okay, hold on. This all sounds amazing, but with AI robots, it's hard not to think about, like, the risks, right? What about safety? What's to stop these robots from going rogue?
That's a valid concern, and safety is a top priority in AI and robotics research. It's not just about the code. It's about building in safeguards, ethical considerations.
So we're teaching these AI robots to be responsible, to operate safely in the real world.
Exactly. We want them to work within defined limits, prioritize human safety, and avoid any unintended consequences. It's a challenge, but one that researchers are actively working on.
Okay, that makes me feel better. So AI integration is one big thing. What else is happening in ROS2? What other trends should we be watching?
Another exciting area is cloud robotics. It's about connecting robots to the cloud, giving them access to massive computing power and data storage.
So instead of the robot doing all the thinking itself, some of it happens in the cloud.
Exactly. This opens up possibilities for really complex tasks like advanced machine learning, real-time data analysis, even super detailed navigation. It's like the robots have a super brain in the cloud.
That's a great way to think about it. And with cloud robotics, multiple robots can share information, learn from each other, and work together even better.
Okay, this is getting seriously futuristic. Cloud-connected, AI-powered robots. I can barely keep up. It sounds like staying current in robotics is a never-ending job.
That's the beauty of it. Robotics is a field that's constantly evolving. It's not just about technical skills, but about creativity, problem solving, and working together.
So for someone listening who's thinking, I want to get into this, but where do I even start? What advice would you give them?
Just start exploring. Dive into online resources, the ROS2 documentation. There are robotics kits you can play with. Experiment, make mistakes. That's the best way to learn.
So get hands-on, don't be afraid to try things out, don't be intimidated by the tech.
Exactly. And connect with the ROS2 community. It's full of passionate people who are happy to help.
It's really cool that anyone with the interest can be part of this. From writing a simple line of code to, potentially changing the world with AI robots. It all starts with that curiosity.
You said it. The future of robotics is bright, and it's being built by people like our listeners who are passionate about tech, innovation, and making a difference.
So if you're listening and you're feeling that spark, that excitement about robots, don't let it go. Dive in, explore, and who knows? Maybe you'll be the one creating the next generation of amazing robots.
I can't wait to see what the future holds.
And that wraps up our deep dive into ROS2. We've explored some incredible concepts, and I hope you've learned something new along the way.
It's been a pleasure.
We'll include links to all the resources we mentioned in the show notes, so be sure to check those out. And until next time, keep exploring, keep learning, and keep that robotic spirit alive.